then we use either likelihood or Bayes type approaches, maximum likelihood or Bayes type approaches to infer what kind of theta describes the graph that we have. So this gives you this nice sort of tight interaction between a model and data. So usually learning is this way from data to model, but then you can check the model in this framework by then generating new data and asking whether the synthetic data looks like the empirical data you learn from. And that's actually very powerful, especially if you want to build a model that accurately reflects the underlying structure of the data, which is useful for science. Although if you're interested in just doing prediction, like at Facebook, for instance, they don't really care whether or not they understand why people actually interact. They just want to be able to get good predictions, and that's a different task. A lot of my interests fall in the side of understanding the scientific aspects of these things. And that's because I like understanding why the world works. And to do that, you have to have a model that is not just good at predicting, but also good at actually representing. OK. So under this framework, you can do several nice things. So if the parameters or the structure is partly known, then you can constrain your inference, and you can learn the rest. So if you only know part of the theta, you can learn the rest of it more efficiently. If the graph is only partly known, like say I observe the social network of all the people in this room, and I want to make some prediction about the social network of some other group of people at Colorado, I can do the same thing. I can infer some structure on our interactions, and then I can use the probability distribution to generate the rest or another instance of a classroom. If the model is a good fit, which of course depends on the application, then we can generate these synthetic networks that are similar. So for instance, if I work for a power company, and I want to understand what the power distribution might be like on different versions of the Western power grid. If I build a model of that grid, I can then generate new instances of the Western power grid and then see what happens if I vary the structure to some degree. That can be quite useful, because it would be unethical for me to try to rewire the power grid by myself. So this allows us to do things that would be either impractical or unethical in a common sense by using the model as the intermediary. And then finally,